Hi, I have a question for you. When we take a material and press it on one side, we observe that all other sides expand. Yes, the Poisson's effect. Can you tell me what happens if you don't press a material but instead bend it? Does it also curve on the other direction? The answer is yes. The same rule applies here. Just like how pressing creates an expansion, similarly, a curving up produces a curving down on the other side. The shape is similar to a saddle that used as a horse seat. This is the everyday materials that we all know typically behave. But very interestingly, there are some materials not engineered by nature, but by us behave very differently. When we bend them, the curvatures on both the sides are similar, forming a dome-like shape. But what causes this peculiar behavior? Let us try to understand this. A plate is made of many layers through the thickness. When we strain a topmost layer, the Poisson effects are produced in the same layer. This is the case with any layer of the plate. But what if we can break this rule? What if we can transfer the Poisson effects in between the layers? That is, if we press the topmost layer, the bottom layer should expand due to Poisson effects. Is this possible? We will show you an artificial material in which this happens. Take 4 bars and connect them through pins to form a square. The length and width of the square changes simultaneously, giving rise to an apparent Poisson effect. To give thickness to the system, we will attach a V-shaped link to the 2 corners of the square. When we deform the ends of this V-link, we observe that the square also deforms. Our task is to now transfer this deformation to the bottommost layer. In order to achieve this, we will connect an inverted V-link to the other 2 corners of the square. This completes a structure that can transfer the Poisson effects between the outermost layers. That is, when we press the topmost layer, the bottom layers expand due to Poisson effects. To make a material of the structure, we will repeat this to create a pattern. This pattern, in the global sense, bends to form a dome shape instead of the saddle shape that we typically observe in usual materials. Currently, we are working to systematically design such exotic materials. Thank you.